Here we have a question. It says X, Q, and R are on a straight line. The angle of depression of a point Q from the top of the tower PX, 25 meters high, is 35 degrees. And the angle of depression of R from the top of the tower is 20 degrees. Calculate QR. And here it is. We need to draw the diagram to see what we're talking about, to have an idea of what it is we're talking about. So here we have on our diagram, and what you could do is pause the video and see if you can draw the diagram. So let's use our information to draw our diagram. It says the angle of depression of the point Q from the top of the tower PX is 25 meters high, is 35. So let's start by drawing our tower. So here is our tower. This is P. This is X. Right? We put X here because it says X, Q, and R are on the straight line. Right? These are on the straight horizontal line. So here is P, here is X. And the angle of depression of Q from the top of the tower PX is, so this tower is 25 meters high because it says that tower PX 25 meter high is 35 degrees. So the angle of depression is 35 degrees. So here we have Q. Alright, and the angle of depression, let's draw our horizontal line to help us to understand. So this angle of depression here is 35 degrees. Alright, now it goes on to say that there is another point R from the top of the tower. That angle of depression is 20 degrees. So from the top of the tower, another point R, angle of depression is 20 degrees. So let's join our points. Remember, they're all on a straight line. Alright, so our diagram should look like this. Now for us to put in our angle, let's just show this a little better. So our angle from here to here, this angle here is 20. Our angle of depression to R, and the angle of depression to Q is 35 degrees. Let's put that there. So what we could do is put our angle of elevation. Our angle of elevation will be 20 here and 35 here. And what we need to do is find the size of the length of QR, the length of QR. And we go about looking this two ways to do it. One way we could do it is find the length of XR. Then we find the length of XQ. And the two lengths, if we find XR and then we find XQ, the difference QR would be the difference between those 2 points, right? So, or the difference in those two lines. So we could, that's one way of us doing it. So let's do it that way first. So let's find QR, or XQ, sorry, XQ. So here we have the opposite and we need the adjacent. And from time and time again, we were doing opposite and adjacent, and we know that the opposite and the adjacent is tan. We have to use our tan ratio for that. Yes, we use our tan ratio for that. So let's find XR. So we're looking at the entire triangle, this long triangle here, the larger triangle, PXR. And the angle here is 20. So tan 20 is equal to the opposite, which is 25, over XR. So to find XR, we transpose, so XR times tan 20 is equal to 25. And then we bring over, this is multiplying, so it will divide. So XR will be equal to 25 divided by tan 20. All right? And we use our calculators and work that out. Use our calculators working that out. And you could pause the video to find what XR would be. Right? Find the length of XR. So, here we have 25 divided by tan 20. 25 divided by tan 20, which will give us XR will be approximately 68.69, right, meters. So the length of from X to R will be 68.69 meters. All right? So from X to R. Now, we need to find from X to Q. From X to Q. And again, we have tan because we were opposite and we need to find the adjacent. So tan 35 this time, because this is the angle we're using, is equal to the opposite, which is 25 over XQ. We transpose, so XQ is equal to XQ times tan 35 is equal to 25. And then we take over the tan 35, so XQ is equal to 25 divided by tan 35. All right? Divided by tan 35. So now we have 25 divided by tan 35, and here we will have XQ will be equal to 68, sorry, I'm copying it, 35.7 meters. So the difference between XR and XQ will give us QR. So QR will be equal to 68.69 meters, subtract 35.7 meters. So take your time and let's do that. So 68.69 minus 35.7, which will give us 32.99. Let's put to round it to the nearest whole numbers, 33 meters, right? So it's approximately 33 meters from Q to R. All right? So what we will do, we will pause and then look at another way we could calculate QR. All right, here is another way we could go about working the question. Now, if we know the angle, the distance we want to find is from Q to R. Now, if we know this side, if we need to know this side and we know the angle opposite, if we can find this side and we know the angle opposite this side, what we can do is use the sine rule to help us work this question. So let's see how we work that using our sine rule. So note that this angle here is 35 degrees and the angle here is 20 degrees. So it means that the angle between here is 15 degrees. The angle between there will be 15 degrees. Now, let's just put in our 15 degrees here. So remember, QR is opposite 15. So what we need to know is a side that the side that is opposite 20. And then we could use our sine rule to work that. So here we have the opposite. We need to find this side, the line PQ. So how do we do that? We have the opposite and we need to find the hypotenuse. So here it is. When we have the opposite and the hypotenuse, that is the sine ratio. The sine ratio opposite over hypotenuse. So sine 35 is equal to the opposite over the hypotenuse, which is equal to the opposite of the angle 35 is px, and the hypotenuse that we need is pq. Right? So sine 35 is equal to the opposite, which is px, which is equal to 25, over pq, that is what we need. And then we transpose and make PQ the subject of our formula. We transpose to make PQ the subject of a formula. So we take our PQ here, PQ times sine 35 is equal to 25. And then PQ is equal to 25 divided by sine 35. So there, we use our calculators now to calculate the distance of PQ. All right, use the calculators, calculate the distance of PQ. So PQ will be equal to 25 divided by sine 35. And that will give us PQ is equal to 43.59 meters. This is PQ. Now, so let's put it in there. 43.59 meters. So to find this length QR, we have an angle, the side opposite, and we have this angle here, and we need to know that side. All right, and this is where we use the sine rule. Sine rule. Remember sine rule. If we want to find a side, in this case it will be the given side, which is PQ. We know PQ over sine 20 is equal to P or QR over sine 15. Now we know PQ, we just found PQ as being 43.59. So 43.59 over sine 20 is equal to QR, the angle that we need, over sine 15. And we transpose that and work it out. Transpose that and work it out. So we take our sine 15 across, so 43.59 times sine 15 over sine 20 is equal to QR. And you can work that out to see if you have the same answer as before, which is 33. So 43.59 multiplied by sine 15 And then that answer divided by sine 20, which gives us approximately 32.99 meters, and then we could round that to 33 meters. So we have the same answer. We have the same answer another way. So you could use whichever format that you feel comfortable to calculate a sine, right? Once you have the correct information to do so. And we'll do one more example, and then I will encourage you to go to the worksheets and work problems based on angles of elevation and depression. All right. So let us look at our final example of angles of depression and elevation. All right. Now this one is a little challenging one, and it says that I hope you would have written the question down as it was given before the video started. And it says that the height of this man, or a man 1.5 meter tall, is standing on a building 48.5 meters high. All right, so let us begin to draw our diagram. So we have a building 45.8 meters high, 48.5 meters high, and there is a man standing on top of this building, and he is 1.5 meters tall. So he is standing on this building and he's looking down. And the angle of depression to as he looks to the top of a building across the road, so there's a building across the road, and as he looks to the top of this building, now we know it's not as high. It is not as high as the other building because he's looking down to the top. The angle of depression to the top of this building is 25 degrees. The angle of depression to the top of the building is 25 degrees. So he looks down here. This is his angle of depression. Let's draw our horizontal line here. And this angle of depression is 25 degrees. And he says the angle of depression to the bottom of the building, so this is the bottom of our building, all right, this is the bottom of the building, and that angle of depression is 40 degrees. So here we have an angle of depression of here 25, and this angle of depression here is 40. All right, now let us label some of the sides. So we have, let's label them A, B, and A. So this will be AB, will be the height of the man plus the building, and the total height here will be 48.5 plus the 1.5. So this total height of the man and the building, the total height of the man and the building will be 50 meters. 50 meters. All right? 48.5 plus the 1.5. All right, we know our angle of depression would be given as 25 degrees to the top of the building, 40 degrees looking to the bottom of the building. Now, the question asks, the first part of the question says, to calculate the distance to the bottom of the building, to the base of the building across the road along the line of sight. The distance to the bottom of the building across the road to the according to the line of sight. So what the question is asking for, along the line of sight, we want the distance from A to the bottom of the building along the line of sight of this man. So he's looking down here. This is his line of sight to the bottom. So we want to calculate the value for AC, the value for AC. Now, how would we calculate that? We know the height here. The total height is 50 meters. Now, do we know any angle here? Now, we know this angle of depression here is 40, and we said that the angle of depression will always be equal to your angle of elevation. So if this angle is 40, this angle here will also be 40. So now we can calculate this angle or this length from A to C along the man's line of sight to the bottom of the building. We have the opposite, and what that is, AC. AC represents the hypotenuse. So if we're dealing with a right angle triangle and we have the opposite and the hypotenuse, which ratio are we speaking about? Yes, that will be our sine ratio. Our sine ratio. And sine tells us that the opposite sine theta is equal to the opposite over the hypotenuse. All right? In this case, the opposite will be AB and the hypotenuse AC. All right? And we need to find the value of AC. All right? So, sine theta, in this case, sine is 40. Sine 40 is equal to the opposite, which is 50. Remember, the 50 is the height of the building plus that of the man himself, right? So sine 40 is equal to 50, the opposite over the hypotenuse, which is AC. That is what we need. So we will transpose to find what AC is equal to. So let's carry over. So AC times sine 40 is equal to 50. Therefore, AC is equal to 50 divided by sine 40. So work that out on your calculators and see what you will have. 50 divided by sine 40. Divided by sine 40 gives us approximately 77.79 meters. So therefore the distance of A to C along the man's line of sight, the distance from the man's from the top of the building to the bottom of the building on the other side of the road along his line of sight is 77.79 meters. So let's put that in here. Now, what next thing we're asked to find is the height of the building. The height of the building. We want to find the height CD. So let's look at this triangle and let's note some things we can observe. One thing we can observe is that if this is 40, the entire angle is 40 here, and this angle here gives us 20 or 25, it means that the angle here will be the difference between 40 and 25. So this angle here will be 15 degrees. So the 15 plus 25 will give us 40. So we can find that angle here. We know that if this is a right angle, if this is a building, it means it's horizontal and it forms a right angle with, this building will be vertical and it forms a right angle with the horizontal. So the vertical building, the horizontal line forms a right angle. So this will be 90. So if here is 40, the angle here, we're given here, will be 90 degrees minus 40 degrees, which will be 50 degrees. So our angle here is 50 degrees. Remember, what we're trying to find is DC, and we want enough information to see how we'll find DC. So here we know this angle, and DC is opposite of the angle we have here. We have this length here. If we can find the angle opposite here, we could use our sine rule to find what the height of DC, right? So if here is 50, here is 50, how would we find that angle there? How would we find that angle there? Reminding ourselves that in a triangle, the sum of the angles will always be equal to 180 degrees. So the angle CDA, this is the angle here, will be equal to 180. Take the two given angles, 50 plus 15, which will give us 180 minus 65, which will give us 150. So the angle here is 150. So we have a side and the angle opposite. We have an angle and we need to know the side opposite. So that gives us our sine rule. Remembering, our sine rule here would be the given side, which is 77.79, over the angle opposite, sine 115, is equal to the side we need and the angle opposite that side. The side we need is CD, and the angle opposite that side is sine 15. So you see how we applying all the knowledge we had from our trig ratios, our sine rule, our cosine rule. Well, we didn't do much cosine rule here, but we are applying all of that to calculate, or to use to calculate the sides and the angles, not only in our bearings, but also in the angles of depression and elevation. So let's transpose to find the height of the building. So 7.79 times sine 15 over sine 115 is equal to CD. Right? Will give us the height of the building. So let's work that up. Let's work on that. So 77.79 times sine 15, and that answer we have there, if when we divide it by sine 115, we will have 22.22 meters. 22.22 meters. So the height of this building is approximately, the height of the building will be approximately CD, let's just write it here, CD will be equal to 22.2 meters. All right? So we calculate the height of the building just by knowing the height, the angles of depression, right? We found the height of this building. So persons who might be getting involved in architecture and in the field of surveying, this information will be very helpful to you. All right? So what I encourage you to do, practice the worksheet. Practice these worksheets to help you to understand and get better at it.